One woman died in an explosion at a popular Kansas City restaurant after a gas line was ripped open during installation of a telecommunications cable by a contractor using horizontal directional drilling.
1.6 pipeline incidents happen every day. Each year, approximately 700,000 underground utility pipes are struck during excavation work. The fact is that under our feet and across the country, there are several other utility lines like telephone, steam, gas, propane, water, and electricity. If you hit them, some can kill you and all will definitely cost you. Now let's discuss what current techniques are we using to detect the underground utilities. Iron pipes and joint detector, buried cable detection technology. We also have these equipments for wide area mapping. There are a lot of equipments available, but as we can see, these equipments and technology is manually operated, time consuming and hefty sizes. To counter the drawbacks of these existing technologies, we would like to introduce the concept of integrated utility detection system. This integrated utility detection system is a device which uses high frequency and high penetration power sensors combined with a drone. With this new technology comes a challenge that a drone which is flying at a certain height from the ground, will that device be able to map the underground things as accurately as the devices which work in with the direct contact with the ground? Use of sensors is not new in the market. So if we can develop the sensors which are of such high strength and works with the strong radiations, then this concept can definitely benefit and change the game of manual utility mapping. Now let's discuss stepwise how this technology will work. Step 1 is data acquisition. Sensors on the drone will detect and locate the position of underground pipes and cables. The step 2 is the data logger. The data detected can be logged into a tablet or using a PC controller. Third and final step is to obtain the output. The output is generated in the form of a map, which is automatically transferred to 3D CAD file. Also, the 3D view of the utility network in CAD and GIS environment is available. Here are some examples like how our data will be seen after using this device. Having discussed the challenges and the working of this device, the question arises that why do we even need this technology? Let's find out.
The drone can be used in the construction projects with uneven topography. When the project is located on very rough terrain, it is difficult to use heavy, manually operated devices on uneven surface or the areas which are hard to approach by people. However, as the integrated underground utility detection system changes the mobility of detection device, the contractor doesn't need to move heavy devices to the site, and the operator doesn't need to be on site either.
Now let's talk about the potential weaknesses of this technology. We are using the term potential because this technology has not been developed yet. It's still in the concept phase. But if in future we happen to develop this technique and it comes into reality, then one hazard that we can preconceive is to human health. This is because our sensors are using high radiation. They have high penetration power, which can be harmful to humans. If it happens to be true that these radiations are actually dangerous and hazardous for the human health, we can easily overcome. The operator does not have to be in contact with the radiation. We can make sure that where this drone is being flown, the humans are not in that vicinity. To conclude, I would like to use the saying that necessity is the mother of invention, and behind every invention there is a new idea. And today we have both the necessity and the idea. I would like to sum up this video by saying that this concept holds the potential. If this technology comes into reality, then this changes the entire game of utility mapping which is done manually today. It adds a new angle to the mobility process from sweeping to flying. This technology, as explained earlier, has benefits like time saving, cost saving, labor, and most importantly, it gives us the accessibility to the places where those manual equipments cannot reach. But not to forget that through this video we have just introduced and proposed the concept. To make this concept into a reality, there is a requirement for further research and development. Accurate detection of the underground utilities can save cost, time, and lives. So let's make it happen. Thank you.